If you like my dad's videos, please subscribe to QA Insights channel.
Thank you everyone for joining this week's Clubhouse meet. Let us get started. So before that, I have a couple of announcements. So this session is being recorded and you can watch it in my YouTube channel today or tomorrow. And also Clubhouse has a new feature called replays. So this session again, it is getting recorded within Clubhouse. Anytime you can go to this room and then you can replay the conversation. So there are two ways you can listen to this session. And this week's sponsor is Redline 13. So if you want to run a high scale affordable JMeter test or other test, you can leverage the Redline 13 platform. So they have been supporting us since the beginning. And there are other couple of sponsors I have got. So eventually I'll be announcing them. And Redline 13 is conducting another conference. So if you're interested in speaking in that conference, please let me know. I can help you out and then you can present your performance topics in that conference. And last week, I don't know how many of you attended GrafanaCon. So in GrafanaCon, there are a couple of updates with respect to K6. So probably we can discuss in the next week's Clubhouse. I can invite someone from Grafana team to explain the features. So those are the couple of updates from my side. And without any further ado, let us start with this week's title, Automating Performance Test Results and Analysis. So we have Joey with us. Hi Joey, how are you?
I am great, Naveen Kumar. I'm great. How are you?
I'm good. Thank you. Thank you for joining us. Actually, I've been meaning to contact you from past couple of weeks. Yeah, thanks for agreeing for this session.
Oh, no problem. Always happy to join these kinds of things, share knowledge, and talk about performance, even on a Saturday evening.
Thank you.
For me, it's an evening now.
Yeah. So where are you based out of?
I'm based out of the Netherlands, so the south.
Okay,
yeah.
Cool. So what is the time there right now?
It's 5 o'clock.
5 o'clock, okay. So I'm ruining your Saturday evening.
Oh yeah, we've got new lockdown rules, so there's not much to do in on a Saturday evening nowadays.
Cool. Okay, thank you. So why not you introduce briefly about yourself and then we can go into that performance testing concepts.
Of course, thank you. Yeah, I'm Joey Hendricks. I'm based out of the Netherlands. I come from the, not around Amsterdam or Den Haag or Utrecht. I come from the south, so very close to Germany. I live there with my girlfriend and I work for APG, which is a very large pension conglomerate, and I'm a performance engineer there, and I solve performance engineering problems, help APG make their applications faster. One of these things that I've been tackling it with, and it's also the subject of my PAC presentation for the Performance Advisory Council, hosted by Tricentis, I think last month that was there. And also one of the other podcasts that I did with Test Guild, with Joe Calianto. And we talked about automating result analysis. So what I usually always see is that when people automate result analysis, they either use like a very basic check. They either just push through SLAs, so they'll have a bunch of SLAs set up that they get defined by the business. If the test meets those criteria, it's good to go. It goes straight to production. Or they have some kind of average check where they just check if the average doesn't change too much from the previous test to the current test, and then they'll just pass through production, which is okay, but it's not that great if you really want to be able to make decisions in a pipeline. So SLAs and any kind of requirements that you put in your test is obviously very helpful, but usually they are defined quite high, higher than they're actually needed. And because of that, stuff can slip in and performance can degrade, even if the service was usually 50 milliseconds on average. Now it's 100 milliseconds on average. It has an SLA of 1 second. Yeah, nobody cares. But we did just slow down with 50% if you move to 50 to 100 milliseconds. Usually it doesn't really matter, because what happens with the impact, so you look at how your users behave. A human can't really measure 50 milliseconds. Really, you can't feel that. But what usually happens is in the grand scheme of things and in the entire application, when performance changes, it's not very nice when it changes to for the worse, and you kind of want to capture changes. You don't want to capture actual. You don't want to just steer only on SLAs. You kind of want to see when stuff changes, when stuff gets interesting, when you want to look at it, and when stuff starts to change and starts acting differently. You kind of want to see what's happening here. Is this bad? Is this good? And that was kind of the moment for me. Like, I need to automate my result analysis, and I need to do this better than just set some SLAs and check if the average is okay. So I started to dive into statistics and to see, like, what is there in statistics to actually use to properly automate an analysis. So statistics, yeah, it's difficult. If you've studied it in school and you had to do exams in it, I envy you. It's such a difficult topic, but it brings so much value to the table, especially for performance engineers. And I don't even think that you're going to be tackling very heavy statistics, mathematician stuff within the performance engineering context, but in that field, there's so much goodies that we can use, and we already use a lot every day. Most performance engineers, you hear the terms like the 99th percentile, the 50th, the median, average, standard deviation. They're all, or the variation. They're all words that you have seen floating around. Other performance engineers might have said it, and so performance engineers always use a certain amount of statistics. So before I started diving into this topic, I was like, yeah, I know what a standard deviation is. I know all these things, the basics, you know. How hard could it be to learn a bit more? Well, pretty damn hard. There is a lot that comes into play when you go into statistics. So I started researching, and I found a couple of values. So in statistics, they have this thing called statistical distance. It's a way to measure how two populations, how much distance there's between them, or how much change. And two numbers or two metrics that I really found very interesting was the Wasserstein distance and the Kologomov-Smirnov distance. There are two distances, and if you watch my back presentation, you get a more visual feel for it, because the two, the KS, I'm going to short them down a bit, the KS, the Kologomov-Smirnov distance, and the Wasserstein distance, they are quite hard to understand if you don't have a visual example in front of you, but it's not impossible, of course. So if you have if you want to have a bit more context, I would recommend to check out my GitHub, where I also have all of this documented, or check the recording of the Performance Advisory Council from earlier this month. Oh, sorry, last month. And what we have is, for example, and I'll start with the Wasserstein distance. It's basically a metric that gives you the overall change between one test and another test. So if you have the baseline and the benchmark, and you want to compare those two, the amount of difference there is between those, the Wasserstein distance represents that in a number, and represents it in quite a logical number, from 0 being absolutely no difference. So if you would calculate that number from two same samples, it would provide you with a 0. So you want to be as close to 0 as possible. And that's great, because if the higher that number becomes, the more distance has been introduced, the more has changed. And if we then classify and categorize that number, saying like 0 to 1 is no change, that's all okay. 1 to 3 is this amount of change. 4 to 5 is this amount of change. You can classify them, and then you can put a impact label or letter rank attached to them. So that's great if you want to classify the overall amount of change. But just having the overall amount, being able to quantify how much the overall amount of change is not enough. You also want to check how much absolute maximum change is there in the test. So it could be, if you snip out some of the outliers, you can measure how much is the maximum absolute distance between your baseline and a benchmark, and that's the Kologomov-Smirnov distance. And if you go on my GitHub and all kinds of or see the recording, you'll see that I always make these graphs, and they go as an exponential, so from left to right all the way to the top, and I plot two lines, and the biggest amount of difference between those two lines, that's usually the maximum distance, aka the Kolmogorov-Smirnov value, Ks value. So that's also a great value because it tells you exactly what's the farthest point from point A to B. And together with the Wasserstein distance, these two values, they can actually tell you how much difference there is. And if it's a lot, if it's a little bit. But it doesn't tell you if that distance is going to be positive or negative. You know? I just want to be able to detect the distance. So that's also what I do with my performance tests. So we run our performance tests. I use Neoload for a bit of context. I run my Neoload script. It exports my data as raw. It's very important. If you do anything with statistics, your data has to be raw in its raw format, so the raw data. If you have the raw data out of your test, then you can calculate these values out of it. I do that using Python. So Neoload exports the file. I eat it up with Python, calculate those distance, and now I rank them. I rank them from S to F. And I'm using the Japanese grading system, which if you're a bit familiar with how the Americans do that, with A is super good, B, same goes with the Japanese one, with S being like super excellent, A good, and so forth, until you reach F, which is absolutely horrible. And it does, and those letters don't represent if it's good or bad, it just represents the amount of change for me. And if I have an S, then I know, yeah, those tests are completely identical, I don't care about them. This can go straight to production. But if I get, for example, a C, right, and there is a significant difference between them, then I want to look at them. Then I want to hold the pipeline, and I want to manually look at them and see what's happening here. If it's in my degrees of normalcy, I don't want to do anything. I want to just let it go. It goes straight to production without anybody looking. But once it becomes interesting, I'm going to look. So you can imagine if you can put labels on these things and say, for example, I have a C, and in my case, I want to manually look at them. So the pipeline holds, I manually look at the test, and I say, that's good. We had a performance improvement, we were expecting that. I copy the results, send the team an email congratulating them on the good work. We managed to improve the system performance. But if it's a slowdown, well, then I'll create a defect, do a bit of preemptive analysis on it, and I start contacting the teams and starting to look into the problem, and the pipeline is halted at that point. So that gives me a lot of control on my in a CI/CD pipeline on that point. But you can imagine that if you have these letter ranks representing impact, difference, or change, or how you want to look at it, and you can actually just say, like, okay, if I have a C, I am going to hold the pipeline, I'm going to fail it, I'm going to create a defect that's going to be automatically assigned to these teams. I'll analyze the data a bit further, and I'll see, okay, I have these transactions that are changing the most. I know that's part of this team. I'll make sure that the defect gets created on their name, and I'll send all the test results with them, and I start contacting that team automatically. You know, that can be all done automatically if you use Python or whatever to just automate that process. You could also say, if we have a B, for example, a little amount of change, that you could say, like, okay, I have a little bit of amount of change. The benefits of releasing it into production outweigh the impact that I have performance-wise. So I'm just going to go to production, and I'll solve it in production. I'll just let it go. I'll take the hit. So this gives me these letter ranks. They give me the ability to take risk because I know how much risk I'm taking. I can clearly quantify that and say, like, okay, you're taking an S, it's super. You don't even have to think about it. Or you're going to have a B, so a little bit amount of regression. Or users aren't going to notice it, so you can just deploy it to production and we'll solve it in production, giving us the benefits of actually releasing the new code and all the new features that are in it, which we usually want, because that also has a benefit in itself. Because of that, we can take risk and solve it in production and monitor it in production. But it all depends on what you want to do with it. You could also say, like, okay, if you use the Wasserstein and the KS value to determine how much distance there is, so if the distance is too much or too little, but you can also then use an average to just check if the average is higher or lower. I have a performance improvement. I'm going to take way more risk if I have an F and it's a performance improvement. I can say, yeah, deploy to production, or I can say, hold, wait, I want to look at a F that is a performance improvement, because how in God's name can we have such giant improvements in our response times and still be completely functional and okay? So you can also catch the weird stuff happening. So with these two values, you can use, you can really see, okay, I have the KS value and a Wasserstein, and I can classify them, and you can create something which they call a heuristic. It's basically performance test results are complicated, and systems that we are testing are complicated. And a heuristic can make us make sense of complicated data in a complicated environment very quickly. So we can take rules of thumbs. If we know that these values hang around these kinds of numbers, we are going to take these actions. If the error rate fluctuates above 20%, we're going to take action and fail the build. If the throughput suddenly changes from our test, which shouldn't happen, then we're going to fail the test, and we're going to look, why is this happening? If we suddenly have a longer duration of test, then we're going to fail the test and look what happened. So you can set all kinds of actions in this heuristics, and you can create basically like a task list that needs to all be verified. And if they're all the tasks go green, it goes to production. And if everything stays in the degrees of normalcy, it goes into just goes to production. And if something happens that is different, so we detect difference with, for example, the Wasserstein and KS distance, then we're going to see what are we getting ourselves into? Are we releasing faster software? Are we releasing a B rank that's faster? Or are we releasing a B rank that's slower? It completely depends on what you want to do, in a sense, like also what your business and a team, how you want to manage your risk. It completely depends on how you want to tackle that. But it's a great way to do this. But ranks, right? They show a degree. You know, that they tell you like it's an S is between 0 and 1, so that leaves a lot of room for error and stuff to still slip in. So you can also use these values together with a 99 percentile or 95 percentile or whatever fancies you. You can also add those values into your heuristic and score them. And you can use a score from 0 to 1. And the more boundaries, for example, are broken by a Wasserstein distance or a Klogomov distance, the lower that score becomes. And that score is quite complicated when to speak about it, but if you visit my GitHub and go through the code that does this, it's quite clear what it's doing. But with the Wasserstein and the Klogomov and metrics that you want to add to it to make it a little bit more tailored to your situation, you can also create a score. And with that score from 0 to 100, you could have a more delicate number that you could use to define it more properly. How much is too much for yourself or for your business, and when you want to take risk and when you don't want to take risk. That's one way of tackling it, using basically a score, or you could use letter ranks. I personally use both. I use a score for myself, so for myself and the technical teams, and I like to use a letter rank to communicate to the business, because I just have to give them a letter. They all understand that. It's easy to understand. It's easy to take risk with it. But we're under the hood. We're using the score to make decisions because it's a more accurate number. But the score can, we know which letter roughly comes across with which score because we calculate both. And then we can also say you're taking an S or you're taking an A. And you can steer on that kind of a way. So it gives you starting to use more advanced statistics like the Wasserstein and Koloromov, and to add stuff like error checks, like how much errors you are having in your test, the throughput, duration, all kinds of extra checks that you can add on top of this. It gives you more control over your test results and allows you to make smarter decisions in very little time, allowing a faster flow to the market, and to allow a better control on how much risk you're actually taking and quantifying it better. Instead of, and on top of all of this could all still be the SLAs, and if the SLAs, if they break, then it's anyways failed. But it does allow you to have more control over what's happening and more impact on what's happening. And that's a bit of the gist about automating result analysis. So I went through it pretty quickly, so if there's any questions, feel free to ask them.
Yes, Joey. Yeah, thank you for explaining your whole GitHub repo contents, actually.
Yeah, that's also what I tried to add at the end. It's a complicated topic, and I especially through audio, it's pretty difficult to explain it, and I don't want to bore you guys, but if you go through my GitHub repository, there is more graphical material that makes this a little bit more easier to understand and to see it all in action. So I would really assure you, if you really want to get a bit of grip on this topic, to check out my GitHub and to see how it's working.
Yeah, sure. So yeah, I have a couple of questions. Let us start with the discussion.
Of course.
So we have beginners, we have intermediate, and we have performance experts in our Clubhouse. So I want to diversify the questions. So if I am starting as a beginner in performance testing, and why do I care about automation? Because whenever I run the test, the tool will give you the results, and then I can just analyze with the APM tools, whatever the tools I'm using. So I just compare it, and then I can present my observation. Right? This is what typical engineer will do, right? So why I should automate, and why not leverage the existing features in the tool?
Great question. I'm also a bit critical about the analytical capabilities of load testing tools. So first, why should you automate? I think there's one word that people really like to use to explain that. Yeah, DevOps. But yeah, automation makes your life easier. Performance engineering is difficult. It requires a lot of communications back and forth with the teams. If I can automate as much away as possible, that's great. I also still have ad hoc projects that I do. I do them once and I never touch them again. So I also run them in Neoload. What I don't do is I don't use any of the analytical capabilities in any load test tool.
Got it.
I generally only look at it when the test is running. If you're familiar with Neoload, for example, and also they're there in LoadRunner, then when it's running the test, right? I either look on AppDynamics or Dynatrace or whatever APM I'm using to see the load happening on the system that I'm testing, or I check it on Neoload itself. You see the response time and how the load is flowing from Neoload. So that's as far as I look on the analytical capabilities of the tool. The first thing I usually do is export the data. I export it straight to a CSV file, and I either upload it to a database, and I have some automation around that to make my life easier in that aspect. And with that automation, I have it in a database, or if I don't throw it into the database and just have the raw CSV file on my disk, in both cases, I always connect the BI tool to it. These tooling, they're made for graphing, and I'm probably the least sophisticated user of these BI tools, because I create scatter plots and some analysis work on these kinds of graphing tools, which allow me to really control the data better. I don't really have to start writing something in Python to snip data away or to throw some outliers away. I can do this really quickly. You can also do this in Excel, obviously, but it's a little bit more complicated. So I always use Tableau to really speed that process up. And for me, it's always been a very big asset to create, first of all, beautiful graphs, which also speaks a bit to the to business owners, and I can better visualize what I'm trying to say here. And what I always see when I share if I would share the graphs that I would, for example, get out of Neoload, it would be not at the same quality of what you would get if we were using Power BI or Tableau, which is Tableau is my favorite from those two tools. But it's not the same. However, it's also very okay. You know, a load test tool is a load test tool, is a load thrower, and I want to use a load thrower and I want it to be as easy as possible. Neoload I always find is great in that because it makes my life easy in creating a test script fast, so I can just test stuff. And then when the data flows out and load is on the system, the real job begins in trying to figure out what's wrong with the system. And so I want to keep my hands off the load test tool as much as possible. I just want to get load on the system and do that in the best way possible, obviously, so realistic as done. And yeah, the analytic capabilities are usually, okay, but nothing great, and that's completely okay in my opinion for the load test tool. So I get why vendors are not really busy with that, but but combining this like Neoload with Tableau or Load Runner with Tableau is amazing because the graphs that you can push out and the customizability that you have, it's really great.
Got it. So I have pinned your profile in the Clubhouse app. So those who want to check out, please check the link. So it's there in the stage in your Clubhouse app.
I get that.
So Joey, with respect to, since we are talking about DevOps and automation, keeping our hands off the process. So if you worked on Jenkins, for example, so they have a feature called trending, performance trend report. So it will automatically compare bills and then it will display it in a table view with the green and red color arrows. So why can't we leverage just those to see how my performance is being there between bills?
I'm a bit unfamiliar with what you just mentioned. Also, my knowledge about Jenkins probably doesn't reach that far. I can't really answer that question properly. But what I always think about when I use other tooling, for example, than Jenkins, then, right? If they do some automated analysis, I don't think they're going to use any of the raw data. They're not going to take the data from my performance test and analyze that. And what I always want, I want to be in control because I want to understand what's happening under the hood. I want to know how it's calculated. Because if I know that, then I can also keep that in mind, how it's calculated. What I see a lot is stuff is aggregated or averaged out. If you go to my GitHub profile and go to the automated performance analysis, I forgot how the repo was called, but if you scroll down, there's also a big ass GIF file, and it just shows the average response time, and then the scatter plot gets overlaid with it, and that overlay on that scatter plot, it's really great because then you can see the impact of averages, and and that's always what I always think when I use out-of-the-box tools or stuff that would automatically analyze it. It either is aggregated, for example, and it's you get like an averaged out line, which you don't really. It's not really that handy to have that because it kind of hides away how your application is behaving, and you can see that in that GIF as well. It's a huge GIF. You can find it immediately on my page. I think I've spread it around LinkedIn also a couple of times, but it really shows the impact of averages versus raw data.
Yes. So I am just opened the link. I'm just going over through it. So since you have been using the algorithm, the statistical distance, right? So there are many algorithms out there. In the Python library, we can see a lot of algorithms where we can do this kind of analysis. So why you picked the statistical distance? So what is the significance of it? Why that algorithm?
It's not really an algorithm that I'm choosing, right? It's more or less I'm using an equation. I used the Wasserstein mainly because I was looking on how other fields do this. So I saw, for example, how they do this in medical or just in regular hypothesis testing, and I saw that they're using the Kologomov to check the difference in two populations. And I found these two the first. So I found these two. There are another a lot more of these kinds of calculations that you can perform. One of these is the Kramer von Miss's distance test, I believe, and it's also a great value that you can also use. So I think you also have the Kuhlbach-Lieber convergence test, which is also quite handy, but it all depends in how you want to, what you want to do. I tested a lot of these equations out on my data, and I always noticed that my data, how it reacted to it reacted the best to the Wasserstein and Kologomov. However, energy distance, which is very similar to the Kramer von Miss distance, they're also great distance metrics to really show the difference between two populations. And also these metrics, right, to answer a question a bit better, is also that these two metrics, they're meant to do this. They're meant to represent the amount of distance between them. And that's also what we are doing all the time. We're trying to find how much difference is between one test and the other test. And it is, and that's a bit of the gist that we've been doing all this time. And statistics kind of offers this out of the box. You know, this is still very simple statistical stuff. And when you see the Kramer von Miss, and it's also quite difficult to understand that. Yeah, it's the same reason that you could use a simple student's t-test. So if you've paid attention in high school or remember this from statistical classes in college, a student's t-test is also something applicable here that you can use. It uses the median more, which I don't really like, because the median, again, is like it just as a median and variance check, I believe, and it also tells you a bit how the test is doing. It's also a great way to check is it the same, and you can do hypothesis testing on this too. And what I've noticed the most is that these statistical distances, the actual methods what they use for the real mathematicians use that know a lot more about the stuff than me, they use this for measuring if there is a significant difference between two populations. And with populations, I mean populations of data. So in our case, a baseline and a benchmark performance test.
Got it. Okay. So suppose if I have three populations, three runs, so how this solution works?
Yeah. So first, right, in a sense, how it works on my GitHub, it works. It can only compare two. But what I do is I normalize my data. So I take set A and I normalize it, and I take set B and I normalize it. In a sense, you could take your baseline, so if you have three runs, two baseline runs and one benchmark run. Then you could compare, merge them together to have a more statistically accurate baseline, meaning that we have two stable tests, so whatever numbers come out of the baseline test, they're a bit more accurate because we have a larger population. Same goes with the benchmark. You could make the benchmark more accurate by adding more benchmark runs. So in the sense, even if I have 4 runs, 2 benchmark, 2 baseline, then I could merge them together and make bigger groups out of them, and they'll become more statistically stronger in their comparison. In my case, so in reality, what I usually do, I merge baselines, so I create bigger baselines, and then I have only one benchmark. And that's how I usually do it. I think there is some improvement to be made there, that can be done a bit smarter, but that generally always did the trick for me. When regarding 3 different tests, so when I'm saying, like, we're tested one against version 1 and one against version 2 and one against version 3, then it kind of goes out the window. There are like hypothesis tests that you can do for this, like the ANOVA kind of tests that can tell you how much difference there is between 3 tests. But I kind of felt usually that that doesn't really work in our case. I tried that, but it never really worked for me. And so for me, if you have 3 different tests, 3 different versions, and they're all different individuals in themselves, then this kind of doesn't work. So you really have it only kind of works when you're in that baseline benchmark situation and comparing two populations, unless you're merging populations to become more statistically relevant.
Okay, so we have to take baseline and one good run. That's it.
Yeah, in sense that's usually enough, and it also depends on the traffic what you're getting, right? If you're getting absolutely nothing worth of traffic, then the population goes below how much it is. The same goes for transactions. So in your test, you also have transactions, stuff that you're doing in your test. So if you have some silly how can I put this? If you have for example, 15 transactions, so 15 actions in your test, but one is one of those wonky actions that you can only maybe do 20, 40 times in your test, so you have very little measurements about them. And then on the baseline end, you also have let's say 100, 200 measurements. This could be a very heavy service call in your test, right? If you're testing on the API level, this could be a very heavy service call that we need to have in the test. And it happens, for example, 200 times in the duration of an hour. Very low throughput kind of a test. 200 measurements are quite low quite low for any statistical stuff. It's doable, but it's a low amount. So compared to, for example, a transaction that has 15,000 measurements, they're going to be more accurate. They're going to be more accurately representing the performance in regards to a transaction with 200. So what I usually also do is I calculate scores and ranks on every single transaction, so I can see and tell, okay, listen, these transactions, these groups, they have failed, they're in a bad shape, and I'll tell teams that. But I only will do that once the overall calculation fails. So if I see, for example, if I see a significant amount of distance or change in my overall run, then I'll start looking at the transactions, and only then. I do the calculations and save the information, but I only will trigger and start acting on that information once the overall run fails. And that's mainly because there are transactions in there that could go a little bit wonky over time and act silly, because 5 outliers could really skew how that transaction handles. Yeah, and it depends on the context on what you're testing, because it could be that in my case, a 50,000 a throughput of 50,000 an hour is a lot. But if you work for a telco or a big corporation that has a lot of traffic, it could be that you're like, 50,000, that's like 3 minutes of traffic for us. It's nothing. So it really depends on the context as well. So that makes it also a bit more difficult or harder to manage your data if you have a lot more or low throughput like me.
Correct. So when you say population, what does it contains actually? Timestamp, response time,
it's just usually it's what you get out of Neoload. If you hit the export button in Neoload, you get the action. So first you get the timestamp, obviously. So you get like either an epoch timestamp or one of those logical string ones, and then you get the response time, or you might even get an ID with them. So like this was measurement 001, like you get in Excel too, and then you get the action that you performed. And then you want to have a point after that. Was a failed or a okay transaction? Did I get an error or not? And then it kind of comes up to what your load test tool can do. JMeter is great in this because you can basically completely customize this. You could add information to those data points, saying like, I want to also see the customer number, and I want to see the HTTP status code that got back, or I want to see the response, and I want to save all of that information, and I'll yeet it into a database, and it's in there. All right, and then when you hang, for example, a tool like Tableau on it, you could visualize and even start seeing which customer types are generating higher response times than other customer types, or how many 500 error codes that we get, and how many 429s or 404s that we get, etc., etc., or how many customers from a particular type got an error, and it allows you also to do once you can include information into your raw data, like for example a customer number. It allows you to do also a lot of cool stuff. Saying, for example, hey, I see my error rate go up for a particular group. Something might have flown by functional testing. Maybe I should hold the test and report this. And those decisions can now be made if you have, first of all, access to the raw data and are automatically analyzing your data. There are all kinds of little extra functions that you can start adding to these groups.
Got it. So can I use this solution for any tool, or will it work only with the new node?
No, it really doesn't matter which tool you use. You know, the script that I wrote then, right? It's just a Python script. It's a class that takes two parameters and two arguments, and it just it wants your baseline, and it wants your benchmark, and it wants them as an array, in Pythonish language. It wants two lists with numbers, and those two numbers, they're going to be your response times, and that based on that, it's going to calculate the distance, the difference between them, and then it's up to you what you want to add next. And once you have access to all that data, if you have this loaded into pandas or whatever you want to use, you can start making decisions on it or add your own stuff to it to make it more tailor-made. So this is not the distance measurements. It would work probably for a lot of applications, but if you want to do, you're gonna be forced to customize it a bit if you want to add your own stuff to it. Because for me, for example, 2% error rate is great. It's okay. It's normal. But for you, 2% error rate is probably pretty bad, or also normal, or absolutely horrible. It depends also a bit on the context on what you need to add. I think for the distance, because the distance also uses thresholds to rank and score the test. It could be that if you have an exotic application that behaves a bit more different, that the test results will also act different. So when we talk about that, it also happens a lot like this. So for me, also with the project that I started on GitHub, you can also download one of my test sets and just try it out, see how it works, then load in your own data, and then start tweaking numbers to make it fit in it all. And then you can start building more stuff around it to improve your heuristic, your automated check or automated quality gate, or however you want to call it, or whatever buzzword you want to attach to it. And it allows you to automate it into a pipeline. But if you're using Neoload, LoadRunner, Gatling, K6, or whatever you want to use, it doesn't matter as long as you have access to the raw data, and you can eat that raw data up with a programming language like Python or R or whatever you want to use, because these calculations are quite generic. You can look them up how they work. You can start automating them. So the solution is completely independent of whatever load test tool you're using. It's kind of up to your imagination what you really want to do.
Good. Thank you. Let us take questions from the audience if someone has any questions. So please raise your hands so that I can admit to the stage. Okay, thank you. Hi, Sid. Thank you for joining. Yeah, please go ahead.
Hey, thanks Naveen and thanks Joy for explanation and everything. I have two questions, Joy. Like, is your tool from GitHub, will it also plot a template kind of report? That is one question. And second thing, it's related to automated, like DevOps, whatever you call. So what type of tests you compare, like the regression test only you compared, or what are the tests? Like, let's say, any soak test you compared from baseline to benchmark? Yeah, I kind of follow the same procedure from baseline to benchmark, but whatever you implemented through tool, I'm implementing through the Excel. That's manual process though. So that is the second question, John.
Excellent questions. To start with your first one, I have two types of tests that I mainly do. I have a peak load test, so we just run peak load through my peak load through my acceptation environment, and I have a stress test that I compare. That's it. All of the other stuff, if I do a capacity test, for example, Gesundheit.
Sorry.
No problem. But if I do a capacity test, for example, I compare that manually. But those are those tests that I anyways going to do ad hoc. Once in a blue moon. That's not something that I do automated. So the stuff that I do often, regression testing, which is mainly my peak and my stress test, those are the ones that I have automated, and also have automated analysis around. And your first, you had another question around. Could you repeat that other question again?
So is it your tool will plot any result?
Oh yeah. Yes, it does some stuff because it has some the graphs that I made on most of the graphs, by the way, that are on the GitHub repository. They're generated through Python because I needed to generate a lot of graphs. It would be better to just automate that quickly, so it would save me time. So it has some capabilities in it to generate graphs, but there's nothing in there that really generates an overall test report from those from that analysis. It's actually a great valid point though that could be added to the project. However, what I do in my daily work is that I have my test results stored in a database, and I connect Tableau to it, and that's what I use to really make those dashboards that I also share with the business, and I use with the teams to analyze them. I generally use them only for myself and my team, but the business, the DevOps teams don't really see those dashboards unless there's something wrong and I screenshot it and put it in an email. They generally only have the score and the rank. It's all subjugated into one number for them.
Then how your results sharing, if at all any stakeholders want to look into the results, so you cannot say that based on your ranking it is good to go. Where is the proof? I mean, don't take me negative, but if somebody asks where is the results, so that's where I was asking about the result template. And also I have another question. Allow me to ask. So I know about raw results into Tableau. So I never heard of that. Is there any way we can upload the raw results into Tableau?
Tableau is just a BI tool that you can download on your desktop. So if you have a CSV file, you can just open it up, and I have automation in place that uploads data from Neoload into a Oracle database, and then I connect with Tableau to an Oracle database, and I just eat the data out of there. Tableau is a BI tool, and it costs money to have that tool. I think it's $80 a month or something along the lines of that, but you can't quote me on that. But for me, it's always been a very big benefit to make these things. Come again?
Sorry to interrupt, Joe. So we are using Tableau, but not for that's for production logs though, but not for our log. We can upload and see that.
Our connection is dropping a little bit.
Is it you are not you are less audible actually.
I think I have a poor internet connection. How about now?
Yeah, it's fine.
So what I was asking is,
also, okay.
Tableau for production monitoring and stats, but we never uploaded any CSV file, and I never find the way we can upload and plot the graphs over there. So that was one question I was asking.
Oh yeah, I built that myself. So I've built wrappers around Neoload, and those wrappers around Neoload, for example, when Neoload is done, it will automatically export results in a raw format, and it will then process that file and upload it to a database. So that's all automated on my end. So Neoload or Load Runner is not going to do that out of the box. I've for my automation purposes, I've wrote wrappers around it. To answer your first question, which also asked about the business and stakeholders wanting to see my test results are always open. So if the business owner wants to look at them, they can look at them. Generally, the business trusts me to make when my decisions are that my decisions are good and that my calculations are in order. We also validate in production, and we validate in test. So once we if we see any issues in production that we haven't seen in test, then we're going to either roll back or we're going to solve the issues. So we have a lot of control over what we're doing. And generally, I've been never asked to show any data for any client or my current employer to show me my show test results. Like, I want proof that what you did is well. I've always had to trust that I always was trusted on my expertise on that point. But yeah, they're always open. So if anybody asks, say, can I have the results for my so I can save them and keep them as test evidence? That's always there. They're all downloadable, so the teams can reach it. So, but they've generally never done it, in my opinion. Then, in my case.
That answered my question, Joe. So one last question, but not least, so how about approvals in your organization? The tool which you wrote, do they have to go some security checks and approvals and everything, or just like they are approved?
Oh yeah. It's any big enterprise. It's always that security likes to sniff through your stuff and see if it's good or not. So that's typical. Yeah. For my case, I security checked my code. Asked me, hey, you have some passwords in there. How do you manage that? I do that properly, and that's it. So that's something typical that happens all the time. For me, that was not a hurdle. It was more like a little bureaucratic tick to get in the box. For me, that was no issue. So any type of security department, if they would hold you back on that, that would also be holding back a lot of other DevOps stuff in automating your processes.
Yeah, I'll ask one last question.
Yeah, shoot.
Your voice is breaking, Sid. Your voice is breaking, Sid.
I think I know it. But repeat this.
It's very less audible.
Oh, okay, yeah, we run. I run. Obviously, how you run a test. We run anyways. You run any release. So every time we're going to release software, it goes through the pipeline. We test all our builds, and generally, it also runs the tests every night, even if there is no new build. So I have multiple testing environments. They all spin up, and it's all automated. One is used for daily builds. One always keeps the current latest production version. One is on the next version. That kind of stuff. So we run basically every time we have a relevant opportunity to test. Our tests are running and comparing against the latest production version to see what the difference is. So that's how we do that. So we are currently always testing every day. In the night, these tests start running, and teams in the morning can come back and they can view these results. Like I said, they're all downloadable. Also, I programmed some Python stuff that creates reports for them, so they can download those reports and then look into the test results. Generally, they don't really do it. They kind of only look at the scores and the ranks, and they steer on that. And they have access to profiler information from that happened during the test, and they can look in App Dynamics to see the tests and debug on that. So that's generally how that works. It's quite a typical process.
Yeah, thanks a lot, Joy. Not that clears everything.
No problem at all. Thank you, Sid. Good questions.
Hi, Pawan.
Yeah, hi, good morning, Navin, and good afternoon or good evening, Joey.
Thank you, Bhavan.
Hi. Well, I mean, it's been a pleasure hearing you. With respect to the the deep-ended automation work that you have actually done, and thanks for sharing with us. Because these concepts called distance scaling testing, or measuring the distance between two hops or nodes, and then analyzing and churning out the results, is something new to us, especially because we are traditionally aware of Little laws or Brooks law, or the capacity planning laws of how do you plan capacity on the interrupts and CPU, and queue theories and all those things are pretty much understandable. I mean, I have quite a few questions. So the first question, what I wanted to know is, see, in this typical Scrum Agile model, right? So in the CI/CD pipeline model, I mean, the purpose of that is to actually reduce the mean time to release and mean time to deploy. But however, when it comes to the developers, correct? So first of all, there is something called as aptX score that you are aware of, right? Which basically tells, when you compare between different hypotheses of different, builds within the release. So the aptX score basically gives you an insight of whether this particular build is actually deployable, releasable or not. So that's the first thing. I mean, that's actually a globally agreed and globally followed standard. So that's number one. That is the what I was trying to say is that is actually agnostic, tool agnostic, and stack agnostic. Okay, so that's my perception. That's number one. So when we actually bring the same from the contradicting view perspective, when I actually talk about the computing of what do you explain, right? The Kolmogorov, Smirnov distance, and some other distance stats, which probably I will have to take a look at it later. But my question is, how do I basically explain this to a developer given the complex of the calculation? That's number one. And number two, I mean, I also see that you have created, a different index, right? I mean, different, for a given particular event, whether it's a critical or not critical, and what is the action that needs to be done. So my question is, can we take this as a global standard that can be, actually implied or applied to the existing performance testing delivery framework? So that's my second question. So I think probably I will take it further, depending on your input on these two questions.
Good point. Yeah, if what I've defined in my GitHub repository is nowhere close to a global or a standard that would work on 99% of all systems and 99% of all contexts, that would be naive of me to say that. However, I do think that when you how it's defined on my GitHub page, it would be applicable to a lot of situations. But in the end, it's also that I've said a couple times, really, it all depends on your context. The thing is that the technique of doing it, right, and maybe the numbers that you use, that's going to be global. That's going to be everywhere. So it depends on if you. Yes. So it depends on how you want to do it. It's completely up to you. If you want your test results to be short, if you want to make decisions on certain actions, it all depends on what you want to do. The numbers and the calculations, they're going to be always the same. So I would recommend, if you're going to implement this yourself, is to check how it works for you.
Okay.
So it completely depends on your context. It's like I said, it's all up to you. So it's all imagination. You can make it as sharp and as strong as you want it to have. Like I said, the two calculations that are in there. You can add the error rate to it, the throughput. You completely define it. You can start, and if you have business context, for example, in my context, I have groups of customers, and if I want to see how a particular change have impacted a group of customers, I can calculate that. And if the business would like to know that impact, I can provide them that. And it all depends. And when I talk to developers when I talk to developers, they're usually not really interested in the actual load test unless it fails. They're usually more interested in stuff that's in their own sphere of influence. So I do have profiling stuff that also happens during the test and on unit test level, and that's the stuff that they look at the most. But the actual for how you want to implement it, it's up to you. It completely depends on the context of the organization.
Yeah, I totally agree with you. I mean, basically, you have given us a high level, probably an in-depth skeleton, and it's all up to us how to leverage this as per our requirement. The other question that I had is, so does this? I mean, you said this is not a global standard, but this can be a kind of I would say a baseline to begin with, right? So the question that I had is basically, does this particular calculation, does this also take the network latency and the number of hop points of a data packet and and then the number of nodes and all those things into picture, or irrespective of that, it is just the distance between two nodes or two points?
Nope.
That we are talking.
Just takes end-to-end response time, because that in the end, that is what matters the most. It's that's what our customers feel. So I do look at secondary statistics like CPU, memory. I have thresholds defined around that as well, but they do not define how I define user experience, because that's the only thing I care about. I care about user experience and giving our customers the best user experience that I can. And secondary, I try to make that, I try to create the best user experience possible with the lowest consumption of hardware. That's my secondary point. But first, I want to make sure that our customers have the best experience on our platform as they can get. That's my absolute goal. Nothing comes short of that. If I have to heat more CPU towards it, I'll do that. But the customer cannot feel any pain of that, and that's always how we at least define it. And that's also why I only care about end-to-end response time, and everything else is secondary. I steer on it, so if I have an increase in CPU usage, I'll create a defect for it, but it still goes to production, because it's not impacting my end-to-end response time. And I'm going to validate in production as well if that's not impacting it. If it's impacting it, it gets rolled back and fixed. Otherwise, the customer, my main goal is always to keep the customer happy and to make sure that we as an organization don't feel the pain of a performance problem or an outage. And if that means throwing more CPU at it or more memory at a problem temporarily, I'm completely fine with that.
Okay, and my final question. I mean, I know that there are other audience waiting, but I would like to just put a very brief question to you. How do you see this integrating, or maybe this particular statistical distance integrating with the front-end performance testing, especially when you basically look at when you consider tools like Lighthouse or any other available tools out there. So can this be resonated with them, or it's just that backend and more of HTTP level?
I think it's more of a backend sort of thing. The front end. So when I convert it to my own experiences, right? Usually the front end in a lot of use cases, it can be tested basically on your own laptop. You could test how your browser is acting towards it, and every browser is going to act the same, right? It might be different if you use Chrome or Firefox or Internet Explorer or Edge, but the generally how the browser is going to download that data, it's all going to be the same. So I generally only focus on my backend because that's where I can make the most difference. And if I get asked to do front-end stuff, that's usually very well already managed by the developers. Usually whatever feedback I can give is usually already processed it. Maybe because I worked with a lot of talented front-end developers, and they always thought they always managed to do very great stuff with that. But I mainly focus on backend, and also this mainly only focuses on backend as you need a baseline and a benchmark to compare to, which is difficult if you can't track the changes. But in the sense, if you could figure out how much response times you have from your front end, you could also compare it. It's just math. It's up to you in the end. But I generally only use it for backend, so API testing, which I think is generally what most people nowadays are testing.
Okay, great, Joy. So I have followed you and I'll connect with you on the LinkedIn as well. And thanks a lot for your time.
Yeah, if you have any other further questions, just shoot to me on LinkedIn.
Sure, I'll do that. Thank you.
No problem.
Thank you, Pawan. Yeah. Hi, Eldad. You can go for next.
Hey, Naveen. Hi, Joey. How are you doing? I'm very glad to be here again.
Thank you for joining us.
First of all, big shout out to Joey. I think you bring up a very important topic of bringing statistics or more advanced statistics to the table of performance testing. I think it's lacking today. The comparative analysis, the t-testing that you've been talking about, this is awesome. Big shout out to you. I think it's awesome to bring it up as a topic. Now, I'll continue with a sort of experience that I had, and I would like to get your reaction to this. So I did some testing to a load balancer. So we basically wanted to test whether the balancing is done correctly. And ultimately, it means that the load is being distributed to the different backend servers equally, or as equally as possible. And of course, my way of doing that was to collect, first of all, the information of how much request each backend server got. And then I used the Gini coefficient. The Gini coefficient is used usually in macroeconomics to measure income inequality or wealth inequality. That's what it's used for. And I also use visualization of the Lorentz curve. I'm sorry for the technical stuff, but the point I'm trying to get is when I presented this to colleagues and decision makers, they kind of gave me a look like a madman, like I'm crazy. I'm bringing big stuff that they're not really familiar to, and it's difficult for them to get a hold on this. So I would like to ask you, Joey, if this is something that you relate to, if this is something that you have experienced, and what do you think would be an appropriate way to deal with it?
I feel you. Had the same problems. It's so first my team that I work with, right? They know what they're talking about, and they have also a certain amount of respect, and obviously to me, so they know what they when I say something, and they listen to it and they accept it, and they like, okay, cool, that's smart. And generally, I don't go to a stakeholder with this. Generally, when I go to a stakeholder, I say I have this equation. I'm not going to explain how. They don't really also care, but they hire me for a reason, right? They hire me to help them solve problems, so I have their trust. If I don't have their trust anymore, I'm probably out of a job. So the thing is usually that I tell them I have a score, and this score is generated like this. If you want to know how it works, I can explain to you. It's complicated, but just trust me on my judgment and my team's judgment that this is correct. So usually my product owner knows how this works, and they can put it in more political terms, usually to defend this a bit, also at the upper management. But I've never had a point where management wouldn't say, "Okay, cool, we trust you. We don't, we don't trust you. This, we want to know exactly how it's done." Management always is like, "Yes, okay, cool. So this represents this. This represents this, and you've tested this, and yes, and it's peer reviewed among my peers within my organization." So it's always that's how we roll with it, and I completely understand. If you could start giving a presentation about all those fancy words that you just mentioned, you're gonna have the exact same reaction from from most business people. They want, what they mainly always want is a number, one number, and they want to know how does this number scale. That's why they love averages. They love a median or a 99 percentile or a standard deviation, because this is what a large majority of people already know and accept, and it's in their reach of understanding. And that's also what I have. If I start conveying numbers to management like a product owner, I am talking averages. I am talking median, the 99 percentile. But once I'm talking to a developer, and where I can talk a bit more loosely to, I am busting out the scatter plots and talking with these people, because I can talk on a different level with them. And when I talk to peers, I can become even more technical, a bit more geeky on those kinds of topics. But mainly what I always feel is that teams, that I try to dumb it down for the business, so they get a letter rank that is qualified, and there are going to be numbers attached to that. So if they want to look it up and review it for themselves, then they can do that. So it's always documented or Confluence or something like that. But generally, I try to dumb it down for the business, and also decision making. I try to dumb it down that it's a letter or a score that they use, and to do that way, instead of making it too complicated. The same goes for it makes it more understandable for the business. So I would say, in the case of what you've done with the load balancer, it sounds like really awesome work, but I would try to dumb it down for the business. Try to come up with something like a scoring mechanism or or rank them, and then tell them this rank just means this. If you want to know how it works, here's the page. It's all documented. Or I can show it in a presentation and bore you for an hour. If you want to know how it works, it works. So that's a bit of my take on it.
All right, that makes perfect sense. Okay, so again, great topic, Joey.
Yeah, thank you.
Awesome. Thanks.
Yeah, thank you, Alden.
Great. Thank you, Alden.
I think Sravanti has some questions, I guess.
Yeah, hi. Thanks, Naveen. So yeah, I don't have too many questions, but thank you, Joy, for the. I've been following your blogs, and I'm in your network in LinkedIn as well. So I would like to know, how did you? So you started with certain limitations in the existing load testing tools, correct? When you initially started your analyzing your results, that journey. So what are the skills which you think would be immensely helpful? Say you identified a problem, and how did you start with coming up with your own solution framework? So that's, yeah.
I think I'm a bit biased. I talked about this. So in the past, I've been a Python developer. So I've done Python development, and I kind of, when I made the switch to performance engineering, it was like, okay, time to go do performance engineering, and I'm like doing a lot of manual work, and I'm lazy, so I don't like manual work, so I started automating things. And then I started finding challenges. For example, I really get bored by opening that sheet every single time, looking at it, and then like, okay, no problem, close it. That's how it kind of started for me. And then I grasped at the tools that I know best. So I grasped at Python and my development background to start doing that. You can use any language to do this. So if you're comfortable in R, do it in R. If you're comfortable in Python, do it in Python. If you're comfortable doing it in Java, do it in Java. It's completely up to you. You could automate this in Excel. It really doesn't matter. For the skills, I would say would be required to do this the most logical way. I would say start learning Python, check out the statistical packages that they offer, see how they try to learn as a skill. I think if you learn a programming language like Python and R as an extra skill on top of being a performance tester or a tester or testing in general, it's a great extra skill because it just allows you to automate, get rid of a lot of toil and boring work, so you can bulldoze that aside and you can start doing the things that really matter to you. And for me, that was, working together with the teams and solving issues with them instead of doing run tests, check results. Oh, there's nothing wrong. Done. Spend an hour doing that. And now a program does that for me. And for me, the skill set would be Python or any programming language that you're comfortable with to start doing this, and then just start from the beginning. First automate the execution of your test, and then start the storage of your test results, always in the raw format, and then you start moving towards statistics and doing stuff around that part. It's a process to go through, and I think learning a programming language would be a great first step to start this.
Yeah, thanks, Joey. That answers it.
I think that's it, I guess. Nobody has any questions. Thank you, Joey, for your time. So how we can skill up if you want to expertise in test results and analysis? Any inputs to the beginners?
Of course, for the absolute beginners, I would start learning a bit about statistics, right? I would first start the basics, right, that we all know and love. I've mentioned them a lot, the median, the standard deviation. Start with that. I think most people coming out of high school will know this. But you just learn them, learn what the numbers mean, and start learning a way to automate it. Maybe check out Python, check out R, find a way to automate those tasks, and start coming up with clever ways. You can read the stuff that I wrote for the pack. You can watch the recording where I explain it with my example of a Roomba vacuum cleaner, and you could try to get a way into that. And for the absolute beginners, I would first start understanding the basics around load testing and start working your way up to the other the commonly known stuff, and then start working towards the more advanced level stuff that we're doing with automated analysis. But for me, it's always been the takeaways: learn how to automate and make your life easier, so you can do more with two hands.
Sure. Yeah. Thank you, Joey. Yeah, that's it for this week's Clubhouse. So thank you for joining. So this session will be available in my YouTube channel, and also you can check it out in the Clubhouse app. So thank you for the sponsor, Redline 13, and see you next week with a different topic. Thank you, Joey. Thank you, everyone. Have a good day.
Thank you, Naveen Kumar. Bye. Thank you all. Bye-bye.
If you like my dad's videos, please subscribe to QA Insights channel.